Where you are, I would be having a field day.
Yeah.
Here we are in the math teacher's lair. Okay. Sorry, that's actually a part of the video. So we got through these guys last time. Let me turn this down to half. Brilliance. Okay. Shabam. Okay. We did all of these guys. We did all of these guys. If I remember correctly, I'm pretty sure we finished up to here. And if you weren't here last time, it's up on the on YouTube. All right. I'll stop making that joke.
Like and subscribe.
So now we got this thing. Oh shit. So how do I do this? Does anybody? Go ahead. Sorry.
Use substitution?
You could do use up. I highly argue that you don't need to at all. Notice the if it was just sine x, what would the integral be?
Cosine.
Almost.
Negative?
Negative cosine. Yes?
Cosine's an answer.
Oh shit, oh shit. It's the changing of the gears. I can hear them. Okay. Trig functions find a way to mess this up. So, do you see how the inside function is just linear?
Yes.
Yes? Which means if I try to differentiate something with a pi x inside, wouldn't a pi just kind of come out with chain rule? You guys understand what I'm saying? Are you? Yeah? Okay. Were you? What's your name?
Heiser.
Oh, Heider. Okay.
Yes,
You had emailed me. Good.
I'm just,
And
I emailed you, but I'm not going to class yet.
oh, had I told you to come in and see me or something? Huh?
Nathaniel.
Nathaniel. I don't remember that. So see me after class. Okay.
Damn, Nathaniel.
Probably have more of these. You're gonna have to borrow. You're gonna have to, well, maybe I can do
Daniel's
this.
gonna watch the video.
He's gonna be like,
What the
oh,
fuck?
I'm famous.
So this is a warm-up sheet that we started
Does he need my
last
chain
time.
one?
And I put all my
So-
videos up on
You said you
YouTube to see
chained
the
one?
solutions that we
The
did.
U-chain were like the integration.
Alright.
So you like do the sign on the outside, and then you also
And then, oh, okay.
integrate the inside. Yeah.
I got it now. I got it.
So I really want this to make nothing but sense. So if I have, let's see, what do you got, Jeff? E to the pi x, right? What's the derivative of e to the pi x?
Pi e to the pi x.
Yeah, it would be e to the pi x times the derivative of pi x, which is just pi. So if I want to integrate e to the pi x, I know the answer should be somehow related to this, yes? But if I differentiate this, I get an extra pi I shouldn't have, so I just have to kill the pi that would come out. Does that make any sense? So if I wanted to integrate
Okay.
sine 2x,
It's just like if you got rid of a regular constant.
what would I start with? What should it be related to at least?
Negative cosine.
Negative cosine 2x. But if I differentiate this, I'll get
Over 2.
2 sine 2x, right? So then I just kill the thing that would come out. So in general, if the inside function is just linear, you really don't need to use u sub. Could you use u sub? Oh, sure, of course you can. Right? You can actually use u sub all the damn time if you wanted to. It would really be unnecessary a lot of the time. Let's redo this one with u sub. Even for a piece of paper. Shit.
But just to clarify, you can only do that like when it's linear, right?
Copy A.
Yes.
So like if it wasn't linear, you couldn't do like the chain rule.
Let's redo that.
Yeah.
Help me out. What would you let u equal for this u sub?
Pi
X.
Pi x. And then what would du be?
Pi.
Pi
X.
dx. Yes? Is that cool? So then how do I rewrite this? It'll be integral e to the
U.
u. Now do I have what I need?
No.
Now you gotta pass in that pi constant.
So I need a pi inside, which means I need a 1 over pi outside. Yes? I know some of your teachers told you to solve for dx, and I need to stop doing that. seriously, just directly, I'm just not even gonna beat around the bush here, they need to stop doing that shit. Because that makes people think that some integrals are doable when they aren't. If you just always solve for dx and you have some extra variables, like, let's just erase those. No, if you can't build what you need, it won't work, period. So I need this, I can build it, because I'm just missing a constant. And constants can go in and out of the integral all day long. So if I need a pi there, I just gotta put 1 over pi down. It's sort of like the Raiders of the Lost Ark, the whole golden statue replaced with the sand. Of course, he didn't balance it correctly. Anyway, I'm always, somebody's always not seen that movie, and I'm like, what the shit? So, pi x is u. What's pi dx? du. So then I get e to the u, which was pi x, right? Over pi, isn't that what we just said it was? A lot quicker too, yes? So when the inside function is just linear, it's the answer divided by the slope of it, basically, right? Because that would be the chain rule, would just give it the slope piece. I don't know if that makes sense. You could use u sub if you need to, but I'm desperately trying to save you a little bit of time. When the inside is just linear, who cares? That's easy. Okay, maybe. Maybe. Some of you guys are looking like, start making sense. That shit, okay, fair enough. Okay, coming back to this. Oh shit, did I just write? No, okay, hang on. Thought I wrote right where it needed to be. So, the integral of sine pi x will be negative cosine pi x over pi. And you kill that pi that wants to come out. Why do I not have to put a plus c?
Because it's definite.
It's definite integral, right? So it would be 2 plus c's subtracting, so they would cancel, so why would we write it in the first place, right? Okay, I like it. And anybody have plus c's ruin your day? Anybody forget the plus c's ever?
Yeah.
If you're in my class, I know you did, so hey.
Shade.
So I gotta evaluate this from, where do you go, 1/6 up to 1/2, right? Now, of course, you gotta know your trig. I'm not gonna accept decimal answers when they're angles you should know the values for. If it was cosine of 11 pi over 17, throw that shit in your calculator, right? But if it's cosine of 5 pi over 6, you better give me the freaking right exact answer, not the decimal crap, yes? So if you don't know your trig values, you better do it. You better get on it. If you're not sure how to do that, come see me. Okay, maybe. Right. So if I said to you right now, nobody say out loud, write it down, write the answer down. Cosine of pi over 3. Don't say it, just write it. Cosine of pi over 3. So everybody got something written down? Cosine of pi over 3. Pi over 3, of course, is what in degrees?
60.
60, so you can go there if you need to. So who's got the answer? Yes?
1/2.
Okay, there's a vote for 1/2. Anybody disagree? Oh, you're all like, oh, I'm just gonna find out what happens. 2 over 2.
Root
So,
2 over 2.
oh, root 2 over 2. Okay, we're gonna vote for root 2 over 2. Anybody else? So she's right. It's 1/2. Where is it root 2 over 2? At what angle?
45.
Otherwise known as
Over 4.
pi over 4. I like the middle. That's awesome. Otherwise known as pi over 4 radians. Everybody with me?
Yeah.
Real quick. I don't have all the time in the world, but there's so many cool little things. I don't have all the paper in the world either, apparently. Cosine likes x. Sine likes y. I wish we would teach that instead of SOHCAHTOA, right? When I say SOHCAHTOA, does anybody not know what I mean? SOHCAHTOA? Kick ass, keep it that way. Because it only helps in one specific instance. It only helps in one specific instance. If we taught cosine likes x, sine likes y, you can continue that so much further into everything you do with trig. So what is cosine of 0? It's freaking 1, because it likes x. And at 0 degrees, it's nothing but the x-axis, yes? And then as I move up, less and less of that triangle I get is on the x-axis. There's a smaller shadow. So my cosine is like the shadow of the thing on the x-axis. And that's why it goes from 1 all the way to 0, yes? So the further the angle input is from the x-axis, the smaller the output of cosine will be. So what are the three main well, there's really, so it could be 1/2, rad 2 over 2, or rad 3 over 2. Those are the three big ones. And of course you got the 1 and the 0. So out of those options, cosine of 60 is the furthest from the x-axis without being 90, so it must be 1/2. The smallest one that's not 0. Do you guys, does that make sense? Okay, I like it, okay. Okay, where was I? Sorry. Alright, so I need to do, how do I evaluate this? I do negative cosine, oh Jesus, I'm gonna do 10. Negative cosine of
Pi over 2.
pi over 2 over pi
Minus.
minus negative, right? Is that cool? Minus negative
Yeah.
cosine of pi over 6 over pi. So what's cosine of pi over 2?
0.
Kick ass. Right? Because again, that's 90. That would cast no shadow on the x-axis, and that's why cosine is 0. What about cosine of pi over 6?
Root 3 over 2.
Yeah, so I get root 3 over 2 pi.
Cosine.
Kick ass. Jeff, you've left yourself, oh, sorry. I needed more room anyway. Okay, here's a little bit more. Is everybody cool with that? Is that all right? Okay. And please, dear God, if you need more review that I'm able to give in class, just come see the tutors, right? Don't just sit there and go, well, we'll see what happens. So, this one I was talking to a group about, I don't think I said anything about this to everybody. What do we normally put into a trig function? So like, if I had a cotangent function, what would I normally put into it? What kind of thing?
An angle?
An angle, yes? So cotangent of an angle equals some number, yes? So if I do inverse cotangent to both sides, I'll see that inverse cotangent of a number, these cancel. Inverse cotangent of a number is an angle. So inverse trig functions are angles because inverses invert the input with the output. So normal input is angles, inverse trig, the output is an angle. So this problem says sine of twice an angle. We just don't know what the angle is yet, right? Okay. So let me write it like this just to make it look prettier. I'll write it as sine twice theta, where theta equals inverse cotangent of x minus 1.
That's the game.
No, this is just the first step. My God, Jeff, the word where suddenly had 3 letters. That's good. Okay, so I just did that. You don't have to do this. I just did that just to make it look better to look at, right? You can replace shit with smaller shit in the middle of a problem as long as you bring back what the original, and that's what U sub's all about, right? We replace a big thing with U so we can work with it easier as long as you bring back what U was. Completely allowed. Because can anyone tell me what inverse cotangent of x minus 1 is?
No.
Of course not. So let me call it theta, because that's what we do in algebra. Is if there's something I don't know, I call it something. Give it a variable. Okay. Anybody know a identity for this? Because the problem with this, trig function of an inverse trig should sort of cancel somehow, but the 2 is in the way.
2 sine theta cosine theta.
Yeah, sine of 2 theta is 2 sine theta cosine theta. And remember, what did I say about cosine last
It
time?
looks x.
Cosine is an asshole, right?
Oh.
Here's a beautiful example of where cosine is an asshole. Sine 2 theta is 2 sine theta cosine theta, bam. No question, that's what it is. Does anyone remember what cosine 2 theta is?
Cosine squared theta minus sine squared.
Kick ass. Cosine squared theta minus sine squared theta, or
2 cosine squared theta minus 1.
2 cosine squared theta minus 1, or
1 minus 2
oh
sine
shit,
squared
cosine,
theta.
what the hell? Alright, sorry. And again, it's just a way to kind of remember things. That's all the cosine is an asshole thing is all about, right? So if cosine's your favorite thing, I'm sorry. But, okay. So I can rewrite this as 2 sine theta cosine theta. So that's one thing to think about. Okay. So now, let me ask you what this tells you by itself. Doesn't this say If I rewrote this, doesn't this say cotangent theta equals x minus 1? Is that cool? You guys see how I did that? Right. Just take a cotangent of both sides. Doesn't this set up a triangle? What's the ratio? Isn't cotangent a ratio of sides? That's what every trig function is, a ratio of sides of a triangle, right? So what's on the bottom, of course, a freaking 1. Tell me if this is at all familiar. I can draw a triangle that this describes. Which side is x minus 1? Who remembers what cotangent is? Which side over which side? Let's see what you do without the SOHCAHTOA crap. Yes. I'm sorry.
Sine over sine.
Say again, sorry?
Cosine theta over sine theta.
I'm with you.
Yes.
But I want to know sides of the triangle without this business, right? So,
Adjacent over hypotenuse.
so it's x over y. I like it. So it's the x side over the y side. I like it. So we can see exactly if cotangent theta is the x side over the y side, what's this?
X minus 1.
X minus 1. What's this?
1.
1. There's no question, right? This is x minus 1, this is 1. That's what this tells me directly. It just tells me that directly.
That is terrible.
What does our question look like currently?
2 sine x minus 1.
2 sine theta, cosine theta. See the triangle I drew? Can we figure out what sine theta is?
Yes.
Yeah.
What are we missing?
Hypotenuse.
Hypotenuse, right? Or the hypotenuse.
Where did he get the
So what is the
cotangent theta from?
hypotenuse?
He
Like
took
parabola.
a cotangent from both sides.
Oh, okay.
How do you get the hypotenuse?
Square both sides.
Yeah, so it'll be x minus 1 squared plus 1, right?
X squared minus 2x.
What the fuck?
It's 2, oh, we're gonna read that. The square root of x squared minus 2x plus 2.
Yes,
Math
I like it.
necessary.
Alright, so we'll write that. Maybe FOIL this bad boy out. Square root of x squared minus 2x plus 2, that's what that would be. That's the hypotenuse. I really want, let me stop for a second. What's important is the steps that told me what to do. Basically, any trig of some inverse trig, you want to create the triangle that the inverse trig describes. The inverse trig function tells you the angle. It just does. And the angle has to live in a right triangle because trig functions talk about right triangles. So I can draw the triangle that the damn thing is describing. And so here's my question, right? So now I know what sine theta is. What's sine theta?
1 over.
For my triangle, what's sine theta?
1 over x.
1 over this business.
Yeah.
1 over square root of stuff. Times, what's cosine theta?
X minus 1
X
over.
minus 1 over square root of stuff, right?
Gross.
So the square root of stuff times square root of stuff
Stuff.
equals stuff.
You're right.
Bam!
You're right.
Okay, that was a little fast, but oh. This is kind of cool. I can pick up on commentary from these guys with my All right, that's a very involved problem, and it doesn't come up often enough for it to be something we just can do immediately. But what you got to do is say, do I understand the steps that we're taking, right? And again, this is just another place where trig identity is going to show up. Okay. And how is this useful at any point in any time, Jeff? Well, you could be trying to integrate something, where if you can rewrite what it's trying to say, you can integrate it more effectively. You never know. Okay. Maybe. All right. Okay. So let's come back. If there's no questions on this, we're going to come back to what we just barely got into last time, which was integration by parts. I'll let you guys off the hook here. All right, so we barely got into it last time. So the little bit we did last time, I started with product rule, and that kind of led us to this very non-intuitive result, which was if I have an integral in this form. So what I want to do, I want to remind you how far we got last time. So we kind of proved that if I have an integral in this form, it's equivalent to this. And I've heard my colleagues do this, and I kind of like it. So integral u to v is ultraviolet voodoo. So that kind of makes it easy to remember, right? But I really want you to remember this integration process was built off one of the easiest forms of differentiation. And I think if I said do some product rule problems, most of you guys should be like, shit, yeah, give me that, right? That should be relatively easy. Product rule is relatively easy. And we built this freaky looking thing off of product rule. Okay. Let me go one step further. What if it was, so this is indefinite. What if it was definite? What would happen? Well, this is actually the result of an integration. So it needs to be evaluated between the endpoints. And of course, this would still be from A to B. Get in there. So this would be for indefinite integration. With definite integration, you just have to evaluate the part that has been integrated already. That's this part. And that, of course, will still have those on it. Is that cool? Okay. All right. I like it. So let's talk about a couple things. I want to talk about how this is different from U sub, and then I want to do some more concrete examples, right? Do you guys want any concrete examples? Yes. Or just theory? You want concrete? Okay. All right. So everybody got that written down? I got a little handout I'm going to give you too, so it's got part of this thing on there at least. Okay, so let me contrast this to U sub. If I had to do, here, there's a problem in the homework that looks like this. I think it looks like this here.
Yeah.
Okay. If I wanted to do this by parts, I am not allowed to do something we're allowed to do with U sub. Let's do this with U sub first. And then I'll tell you why you would never want to use this on this. You wouldn't want to use by parts on this. Does anyone disagree with me that this is doable? If that was just an x, is everybody really cool with the fact that U sub works?
Mm-hmm.
What's the inside function?
X squared.
X squared plus 1. Is its derivative in here also?
No.
Yes, it is. Its derivative x squared is x. Now, you guys should be upset at me for saying that, but who gives a shit about constants? You got to make them work. But just to know something's going to work, I just need to know that the variable part is there. If I want, what do I need to have here then? If I let u equal the thing is stuck. I would need a 2 here, because the derivative of that is 2x. And who cares? I can make a 2 show up there all day. No problem. Now, so that would be relatively easy. So let me do this problem instead. Right? So now do you see why this isn't immediately obvious that U sub should work? Because the captured function, its derivative isn't outside. It's got extra shit. Yes? So let's look at that extra shit. Let me break this up. This is the part that I want, right? Because what's du?
2x.
2x. dx. Yes? And then it's got extra stuff. Dadgummit. Good use of space, Jeff. Be quiet, Jeff. So if I let u equal this, then I could do like we said. Don't worry about this. I'll get back to this in a minute. I can make a 2 show up here really easily, yes?
Yes.
So there's my du. There's my u. And then I got this guy just sitting there going, right? So the whole idea of U sub is to replace parts of the problem so all the x stuff gets replaced with u stuff. So at the moment, I've got x stuff still here. But isn't u equal to x squared plus 1? So then what's x squared equal? Subtract 1, right? X squared is u minus 1. So can't I just replace this with u minus 1? Yeah, okay. Let me show you.
With the x that you have right there, the 2x, could you also then just replace that x with root u minus 1?
Oh, I see what you're trying to say.
As if you just...
No. There could be a situation where that makes sense. Here it doesn't, because this needs to be with this to make du.
Okay.
Yeah. Okay. Good question, though.
Isn't it outside of the, it's not inside the root. Could you just move the dx over?
Say again.
Can
Sorry.
you just move the dx?
Of course, that's what I would do to get it together with this. So there's my du.
Right.
Exactly. So there's not a problem there.
Oh, okay.
Okay. That's not a problem at all. The problem is, what do I do with this guy? But now we know what he is in terms of u. This is an integral of nothing but x. I need to make an integral of nothing but u.
Mm-hmm.
It's all about u, right? All right. So now, this integral becomes 2x dx is du. Right? 2x dx is du. I left my 1/2. I'm infamous for that. X squared is what?
u minus 1.
U minus 1. And then I have the square root of what?
u.
U. So I'll write that as u to the 1/2. So this is something I think some teachers fail to show, that you can go further than you think with u sub. You can do this weird little thing. The minute you define u in terms of x, you automatically have x in terms of u. You just have to solve for it, right? It depends on the function to make it, if it's easier or not, but okay. And now what do I do? What do I do with this thing? Differentiate.
I mean, it's wrong.
Okay. Integrate. That's a good idea. Oh, man. Sorry. Okay. Well, what do I do to make it easier to integrate? I don't have a product rule for integration, do I? Unfortunately not. So I just distribute it, right? U to the 3s minus u to the 1/2. Now this is relatively easy. What would it be? U to the
5/2.
And real quick, I don't know if they told you this, but to add 1 to any fraction, you just add the top to the bottom and put it back over the bottom. 3 plus 2 is 5 over 2. And then, of course, out front's going to go to this, the reciprocal, so then when this comes down, it dies. Minus u to the 1 plus 2 is 3, 3/2, 2/3. And, of course, the nice thing here is when I do half of each, I just end up with 1/5. What was u?
X squared plus 1.
Minus 2, yeah, there. 1/3. Is that cool? Because I'm taking half. Bam, bam, bam. U to the 3/2 plus. Wow. Holy shit. Okay. So that was sort of a review of U sub, but also showing you possibly something you might not have seen before, of how else you can use U sub a little further. Okay. The key thing that U sub can do that by parts cannot do ever. This piece, the square root, is it still there? Yes, it is, right? Isn't it? I rewrote it, but isn't that the square root?
Mm-hmm.
Okay. With by parts, if I wanted to do this by parts, I'd have to break this up and make this whole thing u or dv, and then the other chunk would be u or dv, depending on how I want to break it up. I really want that to make sense. By parts, you've got to take every part, you've got to chunk it off, and then take this whole chunk is u and this whole chunk is dv. You can't say the inside of this is u. No, you can't do that shit with by parts. I really want that to make sense. That's the mistake people make with by parts, is they try to kind of look at it as if it's u sub. And what really sucks is we have the letter u in freaking by parts. So you're like thinking u sub, and it's not that. Maybe. Okay. This might make more sense once you actually start doing some problems. All right, hopefully, okay. So let's do this. Let's do some actual by parts problems. That would be really nice. And actually use this thing here. So let's do a classic one. I don't want to do that one because that's on here. Well, that's too bad, Jeff. Let's just do that. Okay. What about the integral of, let's just pick something, Jeff. All right, jeez. X sine x, I like it. Now this doesn't seem much more different, doesn't seem like a very complicated thing at all. But of course, it's a product of functions, and integrals really suck with that. I really want this to make sense. Derivatives have all these rules. If you start with it and then differentiate it, there's rules. Integration tries to do that in reverse, so it can't possibly have the same rules. There is no product rule for integration. Damn it, right? Okay, maybe. So, I want to give you a few ideas here. I need to pick a u, and I need to pick a dv. Isn't that what this says? That says this is your original integral. Part of it's u, part of it. So what could be u? So u could be x, or u could be sine x.
U equals
It
x.
could be either one. Say again?
U equals x and D.
Okay, we'll get there. You're right, but we'll get there.
Okay.
I just want to make sure you understand what's your options. So u has got to be a chunk of it. So it could be this chunk or that chunk. And then dv, does it make sense it has to have the dx in it?
Mm-hmm.
So dv could be x dx, or dv could be sine x dx. Now think about this. Which one of those integrals, which one of the chunks derivatives would become nice?
X.
Yeah, holy shit, it become 1. So in general, if there's a polynomial piece times something, in general, what does that mean? Not always. In general, you're going to make that polynomial piece u, because its derivative is simple, right? Now it also depends on if the other chunk can be integrated. Oh shit. So if the other chunk can't be integrated, it's got to be u. Okay, and again, we're just learning this stuff. So the big thing with by parts is you have to choose entire chunks. You can't take the inside of something like u sub. You got to take the whole chunk. So you had a good point. I'm going to, like we just talked about, I'm going to let u equal x. So then what's du?
1.
Good. 1 dx. There it is. So what does dv have to be then?
Sin x.
Sin x dx. So how do you know you're on the right track? If you take this times this and you get this. All of this. Does that make sense? U times dv has to be what this is. U times dv is what this is. That's a valid choice. Is it the right choice? I don't know yet. I got to try it, right? How you guys feeling so far? This isn't that much worse than U sub, and it's definitely different from U sub. It's got some similarities. So I got to figure out what v is now, right? And of course, what do I have to do to this to get v?
Negative cosine.
I have to take the integral. Got an anti-differential. This is the derivative of v, and I need to know what v is. So what's the integral of sine?
Negative sin x.
Negative
Cosine.
cosine x.
Oh, yeah.
You're good, don't worry.
And you don't do a plus c there.
No, and I'll remind you why, because it all gets collected at the end once you're totally done. Okay, all right. Because again, remember, this next step is going to involve part of it still needing to be integrated. Isn't that exciting? No, I love it. You guys are actually saying yes. You're like, yay! Is that what you're doing? Okay, I like that. Sign language. That's awesome. So now I can just do this ultraviolet voodoo, right? Like, what did you do today? I did a little ultraviolet voodoo, and you're like, is that a certain strain of something? What is it? So, UV is what? X times negative cosine. Negative X cosine X. Is that cool? That is UV. Is that cool? This is what's nice about this. Once you got this figured out, you just put all the shit together. And then you have to do the integral, but this step is nice. You just throw in shit in the right place. Minus, what's V? Negative cosine X. So let me make this a plus. Is that cool?
Yeah.
Negative cosine X, I'll make this a plus cosine X. And then what's du? Frickin' dx. That's nice. So this is what you need to have happen with by parts, is you want this integral, normally, you want this integral to be easy, or at least easier than this was. Okay, maybe. And this is definitely easy as shit, yes? I don't have any qualms saying that to us. Notice, like you said, there's no plus c yet, because I still have an integral to do. I'm just going to collect all my constants in one big old plus c at the end. So then I get negative x cosine x plus sine x plus c. Done. Is that obvious that that would be what this is? If it is, teach me. All right. Right? This is not obvious, but how do you check it, of course? If you had to check it, what would you do? Take the derivative and see if you get this. Okay, we won't do that now. All right, maybe? No? All right, so again, I should have asked you this. How do I know U sub won't do anything for me here? Is there a part of it whose derivative is in there? No, not really, not usefully, no. X and sine x don't do anything with each other. There is sine x, cosine x is not in there. So no U sub wouldn't get me anywhere. That's the first level of, oh shit, it might be that new thing, by parts. And then when you realize it's by parts, I really want this to make nothing but sense. What are the parts of this? X is a part. Sine x is a part. And to be really honest, I did leave out one option. U could have been x sine x. It could have just been that.
Would it have worked?
No. But I just want you to know what you're allowed to do. Okay. Maybe I'll do one that I had down here. Yeah, why not, Jeff? I'll do one that I had down here. We'll do that together. That's kind of going along with what just happened. Okay. So just so you know what your options are, you've got to break this down. The one way to break this down is x and sine x. And dx would just go with whatever I think should be dv. Another way to break this down is dx could be dv, and this could be u. That might work sometimes. In fact, I'll do one where it does work that way.
How do we know which part to pick?
We don't.
You don't? You just have to do it?
No, and look how Joy is saying about it. So here's the thing. Do you guys remember proving trig identities?
Yeah.
You remember that, right? As much as you try to forget that moment in your life, it won't go away. That is the first real place where a part of the problem is to do it wrong. Yes? I mean, you pick something, you're like, let me see, well, that doesn't look like it's going anywhere. And then you're not supposed to say to yourself, oh, I don't know shit. You're supposed to say to yourself, oh, good, I know that doesn't work. Let me try something else, right? It's just a part of the process to sometimes pick the wrong thing. That could be the tagline of this. Integration by parts. You will sometimes pick the wrong thing. I mean, that's just part of it. It's just part of it. And the more you do it, the more you start to develop a sense of when this should be u, when this should be dv, right? But even then, trust me, I still would look at some integrals and I'll pick the wrong thing because they're funky ass integrals. I'm like, oh shit, it should have been the other way or whatever. So it's never like I always know what to do, ever. Okay. Which I don't know how that makes you feel, but just understand it's part of the process. It doesn't mean you don't know shit. It just means that's part of the process. You made a mistake? Great. It's part of the process. Okay. So let's do this. Here's one that looks like it should be really simple. In fact, some people get it wrong because you're not thinking about it the right way. So just to save you any time, the answer is not 1 over x. What did somebody do who thinks the answer is 1 over x plus c? That's the derivative of a natural log, right? So I just gave something away there if you're paying attention. But, so the integral of natural log, we don't currently have a freaking clue. If you know, you know, maybe took Calc 2 before. Keep it to yourself. So, there's so few chunks here. There's only natural log of x and dx. That's it. That's it, right? So, is it cool? I obviously don't want dv to be natural log of x dx because that's the problem. I don't know how to integrate that. So what must u be? Again, I really want this to understood. U can never have dx in it because u has not been differentiated yet. dv needs dx in it because dv is a differential, right? It's a derivative. It has to have the dx part on the other side. Is that cool? So since I don't want this to be part of this, it's got to be this. So what's the only other chunk inside the integral? dx. So this is a really easy example, like a small example of letting dv be dx, but there's definitely other examples got more stuff in it that this could be true. So what do I need to create now? Of course, I need du. What's du? 1 over x? Yes. And I need v. So what's v? X. That's kick-ass, right? So again, just to make sure everybody, some of you guys are looking a little weird. All I did here was integrate. So you pick u, you differentiate it. You pick dv, you integrate it. Because I need du and v. Really is. How you guys feeling better? Okay. Demystifying this by parts business. So there's my u dv. That's what this is. So this I can rewrite this as u times v. X natural log of x. Is that cool? That's u times v. Bam. Minus the integral of v x times du. Oh, now that kicks so much ass, right? Because of course what happens there? Freaking x's die, right? My math is very violent, so I'm sorry. I'll apologize now. Okay, I like it. I can break out the red. So x natural log of x. So what is the integral of 1? X. Freaking x. Is this right? Is this right? There we go. All right. Okay, I like it. Now, just a real quick side note. You could say like this is a plus c, but then this would have to be plus d or something stupid, right? Because this integral has its own plus constant, this integral, so what we do is we just, part of the process is to not include it until the very end. Yeah. Okay, maybe. Okay, so not too crazy, right? So here, let me give you this. We just did one of the examples that I want you to do. On this paper, there's an integration by part side. It's got notes, and then it's got 3 problems. We just did the second problem together, the natural log. I want you to do the other 2. On the other side is notes about u sub, in case you need it. Took my 180. It's the same handout, basically. It's a little bit different. You might want to look at it.
And then they give us the hard ones.
So guys, you see the problems at the bottom there, right? X e to the x, and then x secant squared. And of course I gave you a definite integral. Ha ha ha. Because I'm evil. Pause.
Substitute this.
Now guys, real quick,
Yeah, you can just, so you just evaluate it there, so you do pi over 3, 10, pi over 3 minus pi over 4, 10 pi over 4.
right, that's the one we just did.
Evaluate it there.
You can actually, if you wanted to, just make that something you know, right? If you wanted to. So let's see, what's that first one again? It's x e to the x, is that right? Right, yes? Thank you. The thing about e to the x is u or dv. It's easy as shit, right? This is so beautiful about e to the x. It's a kick-ass thing. So, when you see an e to the x in a problem, it really is what's better for this other piece then. Right? Does that make sense? E to the x could be either one. Integrate, differentiate, it's itself. So what's better for x to make it u or dv? U, because the derivative is basically going to kill it, which will make the resulting integral better. Okay. Maybe. Okay. So I'm going to let u equal x. I got to figure out what u is. All right, I define what u is, and that means dv has to be the rest. Cool. So then what's du? dx. And what's v? E to the x. Okay. And again, we did integrate. There should be a plus c, but it's just part of the process to put all the plus c's together at the end. Okay, I like it. So then this is u dv. It's equal to uv. X e to the x is equal to uv minus the integral of v du. Yay! Right? So you have x e to the x minus
E to the
the x
plus c.
plus c. So this plus c just has all the c's that happen in it. Okay, maybe? That kind of looks very similar to the natural log one, doesn't it?
Yeah, that was good.
It's not exactly the same, but it has a similar kind of format. Okay. Which kind of makes sense because they're inverse functions. They should be related somehow. That's enough, sorry. So let's talk about the real problem. That wasn't much of anything, hopefully. Is that all right? I don't want to say that if anybody had trouble with this. You almost always make polynomials u. Almost always. There will be a problem somewhere that breaks whatever rule is trying to set. So I'm trying to say they're not hard, fast rules. All right. So let's see, what was it again? It's the x secant squared. Is that right? And it's from
Pi over 3 to pi over 4.
Pi over 3 is on the top.
Yeah, it's the upper limit integration.
Thank you. Okay, I like it. So normally with a definite integral, I personally kind of forget that it's definite at first, and then I bring that in at the end because it's a lot to kind of keep track of through the whole thing. But you do have to remember to bring it in at the right place. So forget that it's a definite integral. It doesn't matter. We got to find the antiderivative first anyway. So based off of what we just talked about, what's a really good first attempt at u?
X.
X. So du is dx. Crazy shit. So what's dv got to be?
Secant squared x.
Secant squared x dx. So again, to make sure you're doing this correctly, when you do u times dv, you better get all of this. That's telling you that you got all the parts represented. You can't choose to leave somebody out because it makes it easier. No, it's not going to work. And what's the integral of secant squared x? 10. Okay. All right, you're done. Yeah. So I've got this is my u dv. That's equal to uv. What's uv? X tangent x. And I'm going to evaluate that between pi over 4 and pi over 3. Minus the integral of v du. I like it. And of course, evaluating from pi over 4 to pi over 3. Let me stop for a minute. And this is where some of you guys got to, and you're like, I don't know what this shit integral tangent is. Now, some of you guys actually have memorized it, which is awesome, but you don't have to. Just remember, tangent x is fundamentally what over what? Sine over cosine. So let me do this. If I had this problem, I would do a little side note. I would just do this as a little side thing. This is integral of sine x over cosine x dx. This is an obvious U sub problem, yes? Now see if everybody did the signs correctly, SIGN. What should U equal?
Cosine x.
Because it's stuck. And so what's du? Negative sine x, good. So this becomes the integral of negative integral, right? Of 1 over u du. And what's the integral? Let me stop for a minute. I'm going a little fast, I'm sorry. This shouldn't be that terrible. Hopefully you remember doing exactly this sometime before. So it's a little u sub in an integration by parts, which you should know by now happens. Calculus loves to go, here's the problem, and then part of it is this, and part of it's this. So that's just happens. So what's the integral of 1 over u?
Natural log of u.
Holy shit! And what was u?
Cosine x.
And what's the thing you got to remember?
Absolute value.
Good. And it's plus c, but all right. Well, it's not plus c because it's definite, so that's all. I don't remember. I don't know if all of your teachers told you why it's got to be absolute value. Does anyone remember why it's got to be absolute value in the natural log?
It can't be 1 over 0.
No.
In the logarithm thing has to be greater than 0.
I like it. So if it was just log, no absolute value, it would only exist above 0. But 1 over u exists above 0 and below 0. So the domains wouldn't match if we don't put this in absolute values. Whatever, John. All right. So, okay. That's the reason. I can't do any more. It's just the reason. So let's see what we got. Can we handle this? Can we just kind of do this part, and then we'll put stuff in for this part? Is that cool?
Mm-hmm.
All right. What happens here? So it'll be pi over 3. What's the tangent of pi over 3? Root 3? Okay. And then I've got minus pi over 4 times the tangent of pi over 4. And the tangent of pi over 4 is
1.
1. That kicks ass. Is that cool? I like it, maybe. Okay. So hopefully you either have tangent stuff memorized also, right? Like pi over 6, pi over 4, pi over 3. Or what I do, to be honest, I don't really have them memorized directly. I know tangent has sine on top. So when sine's bigger, tangent's bigger. When sine's smaller, tangent's smaller. So at 60 degrees, sine is bigger because it's close to y. So that's why it's root 3, not root 3 over 3. I have no idea if that helps anybody, but that's just the way I look at it. Now, sorry. Minus pi over 4 times 1, yes? That's what we said, times 1. So that's the first piece. If I just wrote in English, it would be so much easier. Minus, we figure out this integral is negative natural log, so it's plus natural log of cosine x from pi over 4 to pi over 3. Can we stop for a minute? Is that cool? Because we did this integral over there. So I take that result and I evaluate it between those. Why is this a plus now?
Because we're
Because it's minus and
minus.
negative. Kick ass. Now if you put a secant inside, you're going to have okay. So now I just got to evaluate that. So I got root 3 over 3 minus pi over 4 plus natural log of what's cosine of pi over 3? 1/2. Minus, yeah, I'm good. Natural log of what's cosine of pi over 4? That's 2 over 2. And there's really nothing of work to do to simplify this, to be honest. There are some things you could do but who cares? That was a good one. Yes?
That's pretty good.
So just remember, just because we're in a section that talks about this form of integration, doesn't mean other earlier forms can't come in whenever they have to. So understand that. Okay. I gotta be nice to my people in the back. I'll try to stay up higher. Sorry. I'll move it back and forth so you get seasick. All right, stop. Okay, so here we go. I want to do at least one more of these right now. Where did I put you? Do. Get myself straight. Not you. No, I don't want you. There you are. Oh, cool. Okay. All right. So by parts means, now that we know by parts, we're able to do a lot more integrals than we were before. Did I start you back up? Yes. There are some integrals that are required by parts. Let me just show you. There's a very infamous integral that uses by parts in a most interesting way. And you're all like, oh, good. Just be happy I just didn't give this to you in a test out of nowhere, right? So we're going to talk about it together. Nobody's being graded. That's much better. So let me just slap it down here and see what you guys think. That seems very unassuming, right? It seems, you're like, okay. And to be honest, if you think about it for a minute, does it really matter what U or V is, or DV, U or DV is?
No.
They're both kind of equally cool with it. Okay, so let's just try. Somebody just tell me, what do you want to let U equal?
E to the x.
Good, okay. It could be either one, but that's the one I agree is probably a little better. It doesn't matter. We're eventually going to have to do something. Anyway, we'll see. You could make U equal either one, to be honest. But let's say U equal E to the x, so then dV has to be the rest, cosine x dx. So is everybody comfortable now with by parts truly means take all the parts and assign it to one of the two things? That's why we call it integration by parts. It's because we're really creative with what we name things. It's parts, it's integration. So now what's du? dx dx. And what's v? Is it negative or positive? Of course it's positive. You gotta think backwards, right? Damn integration. Whatever the answer is, the derivative better get you back to where you started, right? So you gotta think backwards about it. Okay.
Oh, I'm seeing how this is annoying now.
Okay. We're all gonna catch up to you in a minute. Here we go. So this, all right, I want to make this a little clearer here. So this is what I had, and it equals what? What do I have so far? What's the form? uv, so it'll be
E to the x.
dx sine x minus the integral of v du. What's v du?
E to the x sine x. Yeah, right back where you started.
Almost, right? So at this point, if I wasn't about to show you that this can be done, that we can get to an answer, I wouldn't fault you for going, screw that problem, I'll never end. Does anyone understand? Does it feel like I'm just never going to end? Then I'll let you equal the d, and then I'll let you equal the and it's going to go forever. Shit, right? Do you guys understand? Well, let me try to say what I just said, maybe in real words. If I let u equal this and dv equal that, switches, I'll have another integral. I'll let u equal e, dv equal cosine, right? So at this point, you might think, okay, so this will just take forever. So is this the rest of the class? Is us meeting and just continuing this around the room? And we're all like slowly going insane? Okay, no. I promise you, 2 more steps and we're done. Okay. The trick to this though is you want to do basically the same thing you did at the beginning. So again, this integral, I could let either one be u or dv, but since we let u equal e to the x, let's do it again. So u equals e to the x, so what's dv?
Sin x.
Sin x. Jeff, what the hell? I gotta learn how to use space. U equals e to the x, dv is sin x dx. So what's du?
EX,
E to the x dx. And what's v?
Cosine x.
negative cosine.
Negative
Oh my
cosine
gosh.
x. Sorry. Yeah, they're dx. Again, just understand, with any process or anything, there's always these special cases that have their own kind of unique way of being done. So let's see what happens. So for some reason, I'm going to continue writing the original problem. Pretty soon you'll see why. Minus, now this integral, uv, right? What's uv? Negative e to the x cosine x. Minus the integral of v du. Right? Is everybody cool with it? So I'm just looking at this guy here, right? And I'm putting him, so I got this. I picked his own u and dv. uv minus the integral of v du. So then it'll become plus. Is that cool? Is that all right? You guys see that?
And it'd be plus on the other one too, right?
Sorry.
Parentheses out if you're gonna distribute.
Say it one more time.
Oh, you're just.
Oh, I'm sorry. Yeah, there's a minus sign here, right, from the rule,
Yeah.
and there's a negative sign on the cosine. So that comes
Oh.
plus out there. Is that cool?
I meant the
That's
one-
why that's a plus. Sorry.
One to the left of that.
The one to the left of that.
E to the
On
sin
the
x
outside.
Oh, this
minus-
guy.
minus.
No, on the outside of the
Oh,
problem.
this guy is because it's here.
Right.
Okay, so there's this, and this integral is this from the work we did. Is that cool? I could give you this as its own problem, and we would do it this way. So the result of this integral goes minus the result. Bam. Right? Okay, some of you guys are like, it's exactly like you said. I gotta do the freaking, look at this shit. We got back in this. But that's the key. This
Goodbye.
is this. So let's see. Hold on. Let me do this one little crazy. Minus a negative is plus. And again, minus a positive is minus. So this seems futile, but can't I just add that over?
Yeah.
And they're like terms, aren't they? I have one integral, ex, and another integral, en, blah, blah. So I get two integrals equals this. So then what's this then? I just have to divide by 2. Slap a plus c in there. Holy shit! Sorry. I love this non-reaction happening right now. This is awesome. You know, like, whatever, man. Oh, man. For some reason, it reminds me of that scene in Princess Bride. I must know who you are. Get used to disappointment. Okay. Okay. Get used to this. Okay. Yes.
Can you do the second to the last step again where you
Yes.
combine?
So is everybody cool? This is the uv minus integral dd from this, right? Then I brought the negative through, and then I added this to this side.
Oh, God, okay.
Because now this is equal to that, so I can add them. So it's sort of like, I'm looking at this as a variable. I'm trying to solve for this, which we're not used to doing with this at all. I understand. We're not used to doing that, are we? But of course we can do that shit. If this equals stuff minus this, I just add that shit over and divide by 2, and that's the answer. There it is. If I took the derivative of this, what would I get? In fact, do it. Take the derivative of this result. Do it.
E to the x sin x
Take this,
minus e to the x cosine x.
do its derivative. Do it. If I'm asking you to do a derivative, you should. Your correct response is, of course, hell yes. Give me derivatives all frickin' day. Does everybody Would you rather do integration or differentiation? Shit, yes. So do that derivative. Or if you don't want to, draw a duck so it makes it look to me like you're doing it. Or preferably, do the derivative. All of my guys just sort of stare at the thing. Try something. Do it. It's just a derivative. Don't be scared of it. It's a product rule, right? But who cares? What about the 1/2? Who gives a shit? Put it up front. Let it kind of come for the ride. So what I'm saying is, if you write it like this, then you just focus on the inside because the 1/2 is just going to come for the ride when you did the derivative, right? The constants just sort of come for the ride. So if I do this guy's derivative, it'll be 1/2 times, what's the derivative of e to the x sine x? It's a product, right?
Mm-hmm.
So do the first thing times the second dude plus
E to the x cosine.
first dude times the derivative of the second.
Negative cosine.
Derivative of sine is cosine.
Oh,
Careful.
yeah.
So remember, that's the gear shifting. Now we're doing differentiation.
Yeah.
I understand this. Trust me. And then this guy, derivative of e to the x times cosine x plus e to the x times the derivative of cosine. What's the derivative of cosine?
Negative.
Negative sine. This and this cancel. So you get 2 of these. Half of 2 of these is 1 of these, which is, of course, what it's freaking supposed to be, right? How do you check any integral? Take the derivative of what you got. See if you get back to where you were, right? If I anti-differentiate this to get this, then the derivative of this better be that. That's it, right? Always. Are you guys okay? A lot just happened, Mr. Wall. Where did I lose anybody? That's good. I love it. Somebody's going to be like, you lost me at hello. Shit. All right. Okay. Okay. All right. Let's do one more example of biparts. One that's not freaky like this. This is the freakiest biparts because again, we are so not used to combining like integrals. When has that ever happened before? Never. One more example of this, then I want to do a little bit of discussion about the next idea in the next section. Oh shit. Okay.
7-2 already?
Say again?
7-2 already.
7-2 already. Damn, Jeff.
Day 2.
Let's see. I have one I want to do. Let me see if they give you anything really freaky in the homework.
You said we're doing one more integration by parts.
Yes, we're going to do one more integration by parts.
Can I go to the bathroom real quick?
Of course, always. That's not really too weird. All right, let me do this. Let's put it down, Jeff. All right, let's make it. Is this the same one that was on the paper? Yeah, it's the same one. Oh, let's do it. Let's do it anyway.
Wait.
Don't look at your paper. We'll do this one together. I want to give at least one example that's not as weird as the last one we did, but still involves doing something multiple times. So I've got a polynomial piece, and I got a trigonometric piece, right? Which piece should I make?
Polynomial.
The polynomial. Normally, not always, but normally I would make the polynomial piece u. So what's the u?
Cosine x. I mean, no, 2x. Excuse me.
Ellen, it's okay. So now what am I going to pick for dv? Cosine x dx. So then what's v?
Negative.
Ooh. Alright. Okay, I like it. And just, the real quick thing, you just write negative sign and then think to yourself, if I take the derivative, oh, there's no negative, because if I take the derivative, it won't be what I want it to be. Who cares, right? Just write something down and go, wait, that's not quite right, and then make it right. So, again, the form, ultraviolet voodoo. So what's UV? Minus, right? UV, integral, V, du. Yes, 2x sine x dx. Now, why is this immediately obvious that it's not a freaky one like before? Because this is a better integral than this. Does anyone agree or understand what I mean?
Mm-hmm.
This is a lower degree. So if I do it one more time, this piece will disappear, right? The problem with the other one was it was e to the x here. And it's never going to go away. I don't care what you do to it. Right? It's like the roach of math. Just going to survive nuclear bombs and everything. Just scurrying around. Well, rat roach. All right. So I do this by parts again. Let me take the 2 out of the way. Is that cool? I can take any constant I want to out. So I got that. So what's u going to be?
2x.
I took the 2 out, sorry.
Oh, x.
Just because I just get out. U is x, so then du is dv has to be sine x dx. And now come at me with negative cosine. I like it. So now we got x squared sine x minus twice uv thank you, minus the integral of v, so I'll make this plus, is that cool? Du. Okay, and then we have, oh, let me see, do I want to distribute this thing? I know why not. And that'd be minus 2 times, what's the integral of cosine?
Negative sign.
Sine. Okay. I don't need these really. Yeah. Okay. No like terms there. Isn't this weird? It's kind of polynomial. It's kind of like quadratic in form almost, but it's got trig that's in there. Anyway. Does that matter? No. I just noticed that and wanted to tell you. Okay. All right. So you just have to get in there and try them out, right? That's the only way you're going to know if you can do this or not. So hopefully, whenever I'm teaching, I desperately try to get the groundwork of how to attack a problem. Will there be problems in there that kind of don't do something like what we did? Yes, there will be. So you just try something. If it's not working, you try something else, right? And the more you do, the more you start to make your own connections about when weird things happen and when things don't happen, right? Okay. So we're going to do the tiniest step in the next section, and we'll get out of here a little early tonight, okay? Don't get overly used to it, but we'll get
You got
out.
out late last time. You get used to it.
Say again?
You got out late last time.
Well, I'm letting you out tonight,
Okay.
unless you want to keep talking.
No.
Okay. Everybody's like, the thing you got to remember is, if I let you out earlier, I'm letting myself out earlier, so you know, I have a little more motivation for it. Let me just throw a problem down, see what you guys think. What you got, John? All right, let's start off nice. Now, this is a problem that you could have been, you probably were, you could have possibly given this back in Calc 1. So this only becomes worse when I start making the powers weirder. So this is pretty straightforward. Does anyone agree with me that this is pretty straightforward? What method are we going to use? Do I have to use by parts? No.
You said so.
I can use u sub. Because is there a function in there whose derivative is in there also? Yes. What function, what would I make u equal?
Sine squared x.
No.
No.
Because its derivative is not in there. The derivative of sine squared, who knows what the derivative of sine squared x is? 2 sine x, cosine x. And all that shit's not in there, right? Okay, maybe. Could sort of make it work, but not really. So I want to let u equal sine x, because then what's du?
Negative cosine.
No, cosine x. Doing derivative, I know. So this is what's weird about by parts. Once you learn by parts, you start to not trust u sub entirely. But u sub, I can do this kind of shit. I don't have to worry about the square. Sine x is u, so therefore sine squared x is u squared. U sub is cool with that. U sub can kind of be more subversive and go in and kind of replace a part of something. You know, it's like a, oh, that was weird. It's like invasion of the body snatch, what I think. Just replace, So the square is still here. And what's this? Yeah, exactly. What's this? Du. Okay, so it's not even really a part of it. That's crazy. We could have done this last semester. What's the integral of this? 1/3 u cubed, right? And what was u? Sine x. So I could rewrite that as 1/3 sine cubed x. Crazy shit, right? So when does this get hard, Mr. Wall? Come on, bring it. All right. Bring it.
If you did like sine cubed x, cosine squared x.
Yeah, when I start messing with those powers. All right, what I was going to do is this, right? Here's what I'm doing. We'll do one more of these, and then I'll...
It's like, I'm happy you said that. You're gonna get even worse, actually. I like where your heart's at, kid, but not quite evil enough.
Exactly. Good summary. That's going to happen a lot. I got an A++ in my evil class, so can't become a math teacher without at least an A+.
That's it?
At least an A+. I got A++. Get out of here.
Is that the only?
Oh, this? Gotta brag about my job. Yeah, this is it. This is what I want us to work on. Does anyone see a problem? Why is this one harder than that one?
You can't use
Because there's no sine. I can't let u be cosine because there's no freaking sine. What the shit, Jeff? So, one thing to start to realize, the thing that by parts, I'm not saying this is a by parts, but the thing that makes you realize is you can start to break things up in different ways than you might otherwise think. I can break this up into a cosine and a cosine squared. Oh, that means their time is almost up. So I can do this, right? And you might look at me like,
Still technically.
sure, Jeff, you could do that shit if you wanted to. But does anyone see, what am I, from the beginning, what was I sort of missing that I had over there? I had the derivative of this in there. I had the derivative of something in there. I'm missing a sign here. What's cosine squared? What's the most fundamental identity? Try again? No? Try. What's sine squared plus cosine squared?
1.
1. So what is cosine squared then equal to? 1 minus sine squared. Oh! Now, it kind of feels a lot like that one did. Do you see a function whose derivative is in there? What am I going to let u equal? Not sine squared, because the same problem we had before. It's sine squared x's derivative is not in there.
1 minus
If I let, no, not in there.
Yeah?
Let u equal sine x.
Oh.
Oh, I just didn't.
Right? So again, this is the thing about learning by parts. You start to distrust what you're able to do with u sub. I can make a piece of something for u sub. I can't do that with by parts. I have to take entire chunks for by parts. So if u sine x, what's d?
Cosine.
Is there a cosine x that I can put with the dx?
Yeah.
Yes. You see, that's what you look for. Is there a function whose derivative can sit next to the dx? Yes. Okay, that means u sub works. So how do I write? Cosine x dx is du, right? And this will be 1 minus u squared. All right, that kicks a lot of ass, right? Now this one is one that you might not think to do this. But what was the motivation? I kind of need a sign, S-I-N-E, for this to kind of work with U sub or something, right? I need that. So that's sort of the motivation. You're going to love this word I use for this. Like shucking corn. I can shuck off a cosine. It almost sounds like, I can take one of the cosines aside, and this is related to a trig identity that brings in that other trig function. Does that, you guys with me?
Mm-hmm.
Now, of course, we're getting a little deeper in this, and of course, they're going to involve secants and tangents also, right? Let me give you this, just so you can have it to think about. Here. So this, we obviously haven't talked about all this, but I figure I might as well give this to you so you can just sort of look at it, or don't look at it. Just bring it back next time if you want to. But it's a summary of the methods we're going to use in section 7.2.
That's nice scratch that, so like when I'm nervous. I know. You like put a problem on the board and I was like.
All right. To be honest, I kind of don't like the way this is set up, but look at me, I gave it to you anyway. But we're going to talk about why the procedure they talk about makes sense. So I don't want you to memorize this. This is sort of like just a reference for you. So we're going to talk about next time why each of these things just makes sense. Not something to memorize, just why do they make sense. But I figure I'll give this to you anyway since I got it. You can look at it. All right, that's enough. So if you have any questions or if I need to see you, stay after. Otherwise, I will see you at least next Monday.
When are we applying the FG prime equation that was in 7.1? Or are we just not using that?